All right. Good evening and welcome to Running Medicine Grand Rounds. Thank you to everyone who may be joining live this evening and anyone who may be watching this session at a later date via our YouTube channel. My name is Sara Raiser. I'm coming to you from the University of Virginia Runners Clinic. Running Medicine National Grand Rounds is a virtual series featuring running medicine experts from all backgrounds speaking on their contributions to the running world. These Grand Round sessions are held strictly to 1 hour to keep these sessions short and sweet, barring any technological challenges here. I'm going to introduce our speaker this evening. We'll moderate a Q&A session at approximately 45 minutes past the hour, because I believe that dialogue is a crucial component of these live sessions and want to honor any questions that come up as we go along with these sessions. So please add your questions to the Q&A feature as they come up, and we'll make sure that we try to answer as many as we can at the end of the session. Before I introduce our speaker this evening, I want to let you know that our next Running Medicine National Grand Rounds will occur in June. We'll be featuring Dr. Dan Cushman from University of Utah, and he's going to be talking on identifying tendon injuries before they start. So without further ado, it's my pleasure to present Dr. Brian Conrad, who will be our speaker this evening. Dr. Brian Conrad will be speaking on scientific approach to understanding running biomechanics, application to footwear. I met Dr. Conrad in 2015 when I was doing research in the Human Performance Lab at University in Florida and thought he would be a great addition to our program tonight, getting a little biomechanical view to things. He is currently a senior manager in the Brooks Run Research Lab, where he leads the athlete performance research program across road, trail, and track. He's led an innovative footwear research programs for the past 13 years. Prior to joining Brooks in 2024, Brian worked in the Nike Sport Research Lab for over a decade, contributing to basketball, running, and walking projects, and occasionally skateboarding and breakdancing. Before entering the footwear industry, Brian was a research professor in the orthopedics department at the University of Florida. And there, Brian combined a passion for sports performance and running biomechanics with a focus on clinical biomechanics, particularly spine injuries. Please welcome Dr. Brian Conrad.
Great. Thank you, Sarah, for that introduction. Excited to share with this group today. Let me pull up my slides. Is that coming through okay?
Looks great.
Cool. Yeah, as Sarah said, I'm Brian Conrad, currently at Brooks, and really excited to talk about how we use biomechanics specifically in the work we do here in the Brooks Run Research Lab. So just wanted to lay out the agenda for what we're going to talk about today. We'll go through a little bit of additional introduction and then really wanted to segue into the talk by grounding it in kind of the clinical application of running injuries and how we think about that from the footwear industry. Then we'll talk specifically about kind of the philosophy that grounds the work that we do here, and that's habitual motion path theory. Then we'll talk about a couple different technologies about how this shows up in our different footwear. And then at the end, I have a few final thoughts and happy to take any questions that y'all might have. So as we get started, I realized that working as a researcher in the footwear industry is kind of a different career path. And so I know there may be some students here who are curious like how one might go about this type of a path, or even people in different fields that don't understand how somebody might end up in this kind of a job, being a shoe scientist. And so I wanted to just walk through where I am and how I got here. Not that this is necessarily prescriptive, but this is how I ended up where I am today. All goes back to East Coast. So I did go to high school in Charleston, South Carolina, and then traveled down to Florida. As Sarah mentioned, spent a lot of time in Gainesville. I'm a Florida Gator through and through. While I was there, I got started in biomechanics through the orthopedics department. And so it was balancing the dual aspects of trying to maximize athlete performance and then also helping them to reduce injury risk. So I had a chance to work with a lot of great athletes while I was there. And that led to making a cross-country move back in 2013, where I left Gainesville and moved to just outside Beaverton, Oregon, where I joined Nike leading the research program for basketball. And that involved working with some amazing athletes and taking those insights and trying to apply it to new innovative footwear. While I was there, they had opened up one of the biggest sport research labs in the world. And I had the pleasure of helping to shape the design and implementation of that new lab facility, which is a huge space. I think we had 400 cameras and 52 force plates, full NBA basketball court and turf space. So a lot of different spaces there. I left Nike a couple of years ago and made my way just up the road to Seattle, Washington, which is where Brooks is headquartered. And so I've been here since, yeah, about a year and a half. I lead a team that's focused on trying to maximize performance for athletes, whether they're competing on the road, track, or trail, and looking at that from a holistic perspective. A little bit more about our research lab. So this shows kind of a picture of our lab. We have space for doing running studies in 3 different bays with mocap and instrumented treadmills. Um, we have 4 different disciplines represented in the lab. There's a run behavior or perception group that's looking at trying to understand people's experience when they're using our products. We have run performance, which is our biomechanics function of looking at how people move and the forces on the body while they're running in shoes. Uh, Recently, we've added a physiology group just in the last 2 to 3 years. And so we currently have 2 physiologists who are thinking a lot about running economy and the metabolic cost of running, as well as thermoregulation for athletes while they're competing in different environments. And then we've got a very robust data science team that's helping us to aggregate and organize the vast quantities of data that we're collecting. And so we've got really strong dashboards of our historical data that allow us to look back on all the studies we've done and pull together biomechanics data, perception data, wearable devices that people may have in the field to help understand how people are performing and how our products are performing. And most importantly, the space is nice, but the people who work in there are what really make it special. And I have the pleasure of working with some of the best people in uh, in the industry, and so I feel very grateful for the team. This was a picture taken during we have a annual symposium where we invite the whole company to come visit the lab and learn about the work that we're doing. And we usually hold it the week of Halloween, so everybody's dressed up here for festivities. So as we transition to think how we think about biomechanics at Brooks, I wanted to ground it in our philosophy, and that's what we call run signature, which means that our holistic approach to understanding the runner, their experience on the run, with the promise to provide optimized running gear and personalized experiences based on their individual goals and biomechanical needs. And these aren't just words, and they're not just a research statement. This really grounds everything that our company does through all the different footwear that we provide and how we approach differentiating our footwear and how we communicate it to our people working in the retail stores. That it's all based on the biomechanical needs of runners and how the shoes are designed to meet those needs. And so this is a very unique approach of how deeply ingrained that this philosophy has been in the company. And I hear people at all different levels that will reference Run Signature that talk about the biomechanical concepts. And so I really feel like this view is saturated throughout the company and has become a part of the culture of Brooks. So I want to start out by just grounding us in the clinical problem. I'm sure everybody is well aware of the numbers and types of injuries that occur during and related to running. Um, the first chart is just highlighting kind of the different injuries organized by the frequency. If we reorganize this in terms of location on the body from proximal to distal, you can start to see some different patterns. We see that almost 80% of the injuries during running are occurring at the knee or below. Um, and we don't think that's a random phenomenon. We think that's reflecting the biomechanical reality that the knee is functioning as a convergence from factors that are transmitted up through the foot distally, and then also from proximal hip and trunk mechanics, and that those are meeting at the knee. Specifically, when we think about this kinetic chain, um, there's what we would call the proximal contribution, and that's related to pelvic drop, hip abduction, leading to femoral internal rotation. That internal rotation can impact the knee, leading to increased knee abduction and IT band friction. Likewise, there's a distal contribution. So from the foot over pronation, tibial internal rotation, leading to patellar maltracking, which really we think grounds a lot of the injuries in the knee, and that leads a lot of our focus to think about what impact our footwear has on the mechanics of the knee. And so, as we think through that, I want to start to introduce the concept of habitual motion. Uh, this is a paradigm that's been around since at least 2015 when Benno Nigg published a seminal paper on the preferred motion path, or what we call habitual motion path, um, that defined every runner as an individualized path of least resistance. And that's based on their specific anatomy, their bones, their muscles, their ligaments, and how they work together with a runner's running form to create a path of least resistance that's specific for them. Uh, when this idea was proposed, it was very revolutionary for the traditional way of thinking about running shoes. There had been a long-standing tradition to think about overpronators and neutral runners, and that if somebody's an overpronator, that's a condition that needs to be fixed through stability features and posting. Um, but the shifting the perspective from running mechanics being a problem to be fixed and running movements being a unique path that needs to be supported individually was really groundbreaking. And so that is what formed the foundation of our Run Signature program. And so we've adopted this habitual motion path philosophy, and we think it represents a natural way that joints want to move. And instead of trying to fit everybody into an ideal gait pattern, we start by trying to understand the individual, and that we work with that understanding to see how our shoes can help an individual to best run in this path that's most natural for them. So unpacking this a little bit more, we've done a number of studies over the years to try to dive a little bit deeper in how we think through this convergence of anatomy, running form, and shoe biomechanics. And one thing that we had noticed in an early study in this area was that the people's motion paths are so different from one another, even though they're quite consistent within an individual runner. In this plot, what we're showing is 6 different runners, and you can see repeated trials of of the knee joint as it was moved through a range of motion. Uh, and within an individual, those paths are quite consistent. But when you compare between individuals, you see an enormous amount of variation, not just in the shape of the curves, but the magnitude of motion, and also in the dimensionality. There's looking at 3 dimensions. The coupling is different. The relationships are very different. And so to us, this highlights not that there's a good or a bad motion, but it's just reflecting on the concept that everybody has a unique path, and that we want to try to figure out how we can best support that. This is further exemplified even at very high level runners. This is a series of images that were taken by Ian Hunter at the 2012 Olympic trials for the 10K. So these are very high level runners who are running at the top of their field. And you can see the wide variety of different types of foot strike patterns that you see even amongst this very elite group. And so if we acknowledge that even elite runners who are all performing the same event, competing at the same level, have an enormous amount of variety. Just imagine how much more variety there's going to be in the heterogeneous populations of people that are running with different body types, sizes, speeds, paces, experience. You can only imagine like how much variety there is in the field. So, how do we determine what somebody's habitual motion path is? Um, that's a process that we've worked out in a lab protocol over a number of years. The way we do that is by taking somebody through common daily activities that don't necessarily involve running. And so that includes activities like squats, lunges, walking, going up and down stairs. And then once we've quantified those movements, uh, we ask people to run to see how running changes the way they move. And so in doing that, we define kind of their joint, taking it through those different ranges of motion that defines a habitual motion path. And then we can look at running and see what the motion path is while somebody is running. When we then look at the data, uh, we found that these plots, which are sometimes called violin plots or manta plots, it's really just a histogram of the motion data, the joint angulation over time. And so it collapses into these wide bands where the most common movements occur. And you can think of the extent of this shape as representing the range of motion. And so it gives you greater insights into the amount and the types of motion that somebody is performing. And what we see is that if we plot somebody's habitual movements in this blue shape, that you can kind of see where their activities of daily life and where their joint is allowing that movement to occur. But when they start to run, that actually shifts their movements into this very different range. And so this variable is for tibial internal rotation, but we do this for other variables as well. But the way we interpret this is that the running kind of takes you out of that habitual motion. And what our goal is to provide a shoe that helps support your movements to bring you back into that habitual motion profile. And so that's what our goal is with the footwear that we're designing. And we are doing this not just because we think it's the right thing to do for runners, but we've got data that shows this is going to help their performance in long-term injury prevention. And so I'll highlight a few different studies. Some of these are internal studies that we did in the lab. The first one was looking at people who had lower deviations. And so that's the folks here in these blue dots. That means that they had smaller differences between their habitual motion and their running motion compared to people who had larger deviations, meaning that they were further away from their habitual motion. On the x-axis is energy cost. And we see that people with lower deviations tended to have a lower energy cost to move compared to people with higher deviations. Uh, and this really makes sense if you think of the habitual motion as being the path of least resistance. And if that's somebody's path that is most suited to the way their body moves, deviating from that path is going to require greater metabolic energy to to be at work during that movement. The next study that we had done internally was looking at different types of deviators. So again, we've grouped these into high and low deviators. That is, those who are naturally closer to their habitual motion path or those that are further away. And we saw that people who are further from their habitual motion path require greater peak knee extensor moments while they're running. And so not only does that, and we think this helps explain some of the metabolic cost, is that your muscles are working harder when you have greater deviations. And this was from a study looking at 90 different runners of a range of different types of people. Next study I want to highlight is from one of our external research partners, Stefan Billwacher, who we have worked with for a number of years to try to understand this paradigm. And what he had done was had people run for an extended period of time, up to 75 minutes, and then took MRI of their knee cartilage at different points during that long run. And so he was able to track the changes in knee cartilage volume and over the course of that run. And what he found was that there was in people that had greater deviations, that showed up as greater cartilage volume changes, specifically in the medial compartment, the femur and tibia, and on the patella. And so this is showing that there's actually biological impact to the deviations and how the knee joint is loaded. And so all of this provides strong evidence for us that deviations are an important way to think about runners and an important way to evaluate the impact that our shoes are making. So how do we translate this science into a product? That's really the crux of what we do in the lab, is that we don't write a lot of papers. We don't do a lot of presentations externally. What we do a lot of, though, is trying to take those insights and communicate with footwear designers and developers to try to create products that can help people to find their way back into their habitual motion path. And the way we do that, because we don't make custom shoes for every different type of runner, is that we try to build functional groups where we identify different patterns of runners, and then we try to build shoes that help to support those types of runners. And so I'll highlight three different shoes and go into a little bit more detail on two of these in particular. On the left are runners who we would say stay within their habitual motion path. And so these are people who need a little less support, and the shoe can move with them. We think everybody needs some amount of support, but the shoe doesn't necessarily have to help them to return to their national motion path. That's where they're already at. But the shoe can provide that comfort and stability to keep them in that motion path. Then in the middle, we have a group that has a pretty tight range of deviations, but they're outside of their habitual motion path. And so that's somebody who could use some additional support to help shift their running motion to be a little bit closer to what their body is naturally accommodated for. And so we call that technology guide rails. And then finally, on the right, this is somebody who is also outside of their habitual motion profile, but they have a much greater range of motion. That's somebody who might benefit from a shoe who's doing a little bit more to help support that runner. And so that shoe might limit some of the range of motion and help reduce the extent of that range, and at the same time shift that down to be within their typical range of motion. And the technology that we use in that area is called glide roll. And so this is a way to think about this is personalized biomechanics at scale. We're not making custom solutions for every runner, but we're trying to identify common patterns and find solutions that can work for those groups of people. And then on the other side, we try to help people to identify where they would fit within this paradigm. And so if you go to our website, we have a tool called Shoe Finder that will walk you through a series of questions and simple tests that you can do at home. And the output of that will be a recommendation on which type of these shoes might be best suited for the way you move. It's not the same as doing a full 3D motion capture assessment in our lab, but that's our way of trying to scale out the same philosophy and make it accessible to runners wherever they happen to be. So before we start getting into talking a little bit more about specific shoe features and how we apply some of these findings to the shoe, I thought it'd be good to do just a quick diversion into shoe anatomy. I don't know kind of how much people know about footwear, uh, but thought it'd be good just to level set on some of the terms we're going to be using. Um, and so when we think about shoe design, we really do obsess about every single detail and how those details affect not just the way the shoe moves, but how the shoe is going to interact with the body and affect the way the body moves. And so we're looking at the bevels, that means the angles of the midsole, the grooves on the midsole, even the shape on that midsole. If you look at the bottom of the shoe, there's outsole areas, and we think about the design and coverage of how much rubber, how it's articulated, or how much flexibility that allows in both the heel and the flex grooves in the forefoot. Um, Furthermore, we look a lot at the geometry of the width and how that defines the base of support. Negative space can make a big impact on the cushioning experience. The toe spring, so how much the toe curves up, is going to affect the transition and how the shoe rolls off the ground. And then finally, we look at things like stack height, the heel to ball offset, and the materials that make up the midsole. And so there's no one feature that is going to answer all of these questions, but we think that all of these features work together as a system. And so we're constantly looking at the interaction of these different features, and how there could be trade-offs where you change one thing and that has an effect on a different area that may not have been expected. So now let's talk a little bit about our guide rails approach and technology. So traditional way of thinking about support was through posting. This has been a concept that's been applied in footwear for a number of decades, 30 or 40 years now. And the idea is that on the medial side of the shoe, you provide some type of support or a wedge. And that can take the shape of kind of an abrupt post where it's like crashing into a wall, or a more gradual approach where you've got a ramp, maybe multiple densities of foam that provide greater support on the medial side. And the idea is that will help to reduce the amount of pronation and collapse of the arch on the medial side. From testing that we've done in the lab, we see that it's very effective at decreasing aversion and the aversion rate. But what we don't see is any impact on the knee support. We had started off this talk by highlighting the number of knee injuries and the common occurrence there. What we see with traditional posted technology is that it doesn't really translate up the kinematic chain to the knee. The effects seem to be localized to the foot and ankle. And so as we're thinking about the knee, and looking at those deviations, we think there's an opportunity for a footwear solution that is actually changing how those movements get translated up to the knee. And there's two specific variables that we found to be particularly relevant. One is tibial internal rotation, and the other is calcaneus abduction. Um, and the reason why we focused on those is based on this study from Fisher in 2018, where they looked at the coupling between different motions at the ankle and how that affected knee motion. And what they found was almost a one-to-one coupling of calcaneal abduction to tibial internal rotation, a much stronger correlation than we saw with eversion at the foot. And so what that tells us is that that strong coupling is an opportunity where if we could control that amount of abduction at the heel, that we think is going to have a greater impact on tibial internal rotation, which will then have an impact on the deviations that work their way up to the knee. And so posting is predominantly supporting that frontal plane movement, whereas we think there's an opportunity to better support the transverse plane, the tibial internal rotation. So how do we do that? Let me explain a little bit about how our guide rails system works, the mechanics behind it. Guide rails are foam structures that extend above the midsole, and they function by guiding the movement of the heel. And that movements, as we talked about, are linked to how the knee is going to move. You can think of it as bumpers on a bowling lane. They can guide and support the calcaneus within the shoe, helping to eliminate excessive motion. And on the medial side, it's made of denser foam that extends underneath the foot, similar to a medial post. But what's different is that we don't just provide kind of a medial post. There's also a lateral component. The shape of these components is very specific, and the fact that they are closer to the foot and kind of surround the calcaneus allows it to work with runners, particularly who have a strong joint coupling and a high amount of motion. And so the key innovation from this technology is that these do address the transverse plane movements, and therefore we're able to more directly target the biomechanical pathway of knee injuries. So we've compared how runners respond to traditional posting compared to guide rails. In this plot, this is showing the impact on reducing tibial internal rotation. We saw that 2/3 of all runners had less internal knee rotation with the guide rails compared to traditional posts, and even higher impact on runners who are high range of motion. So if a runner has a greater range of motion, they have even stronger impact from the application of guide rails. But even runners who are closer to who have less motion still exhibit benefits from this. So in conclusion for guide rails part, this is a technology that supports frontal and transverse plane motion of the foot with the goal of reducing those aberrant motions that are transmitted to the knee. And we think this is best for people who have a strong coupling between the foot and knee motion. The next technology I want to talk about, we call glide roll. Uh, the insight for this particular technology came out of an observation that, for both running and walking, there's a lot of injuries that are happening at the knee, but also at the foot. And when we were thinking about walking in particular, we know that there's a huge amount of power generated at the ankle during push-off, and that the lower leg and the calf is working very hard when you're walking. And so what we wanted to look at here was, is there a way to help offload some of that force during the push-off phase? And the concept is that by adopting a rocker rollover shape, that we can help reduce some of that strain that's required to push off the ground. And doing that through a geometry of the midsole. And so that's the shape of the foam. And also looking at the flexibility. So trying to increase the stiffness in the forefoot so that the toes don't have to bend as much during the push off. Furthermore, we've looked at the effect at heel impact and how the cushioning can attenuate that impact force. And we know that through the foam chemistry, we can change the amount of cushioning that is provided. And so if we are able to provide foam that decreases impact force, that can help reduce the rate of loading, which can have an impact on injury rates. Furthermore, we've seen that when we look at the amount of pressure that's required through in-shoe pressure sensors, we see that providing more cushioning and the rocker shape decreases the plantar pressure. And so we help to spread that over a larger area and actually reduce some of the concentration of forces that were observed in the forefoot. And the total effect of this is helping to offload those forces, which then show up as a reduced joint moment during push-off. And so this rocker shoe technology helps to reduce some of that strain on the calf musculature. And so by combining these different concepts, we think that can have benefits for runners who are using a lot of that strain, need more support kind of in the sagittal plane while they're pushing off the ground. And so how do we do that? We focus on the forefoot and try to eliminate some of the flexibility in the shoe, which will then help to accentuate the impact of the rocker shape. And so we still want the shoe to have flexibility during in the midfoot and the toe off. But what we've tried to do is to provide some stiffness and stability under the metatarsals so that accentuates the rocker motion of the shoe and helps to offload some of the work that would be required from the body. And there's a number of ways that we try to achieve that. Some of it is through the rubber patterns. So you can see for one of our more neutral running shoes, like the Ghost, you get much more articulated and segmented rubber, whereas the Ghost Max, which is one of our prototypical shoes using this glide roll technology, the rubber is more uniform and less broken up. That creates more stability. Also, how we engineer the geometry of the sidewalls creates additional stiffness. and we increase the thickness of the foam in the shoe, which increases the flexibility. And so when we measure the bending stiffness of our Ghost compared to the Ghost Max, you can see almost twice as stiff and bending. And so by intentionally creating a shape and the location and the stiffness, we're able to achieve the benefits from this shoe, which then show up in how somebody moves when they're wearing this type of a technology. And so as we look at MTP dorsiflexion and the Ghost Max, we see significant reductions compared to our standard Ghost shoe. And so it goes from range of motion typically around 30 degrees down to 19 degrees. And so we think that this rocker with the engineered stiffness and reducing that bending at MTP can benefit various conditions where that may lead to increased pain. And I had mentioned earlier that we've seen reductions in plantar pressure. Here we look specifically at how that shows up across different shoe conditions. And so this was comparing the Ghost with two of our Max shoes. And you can see that when we look at the Max shoes with a rocker, in both conditions, they're reducing that forefoot pressure required during push-off. And we also see that showing up in the work required at the ankle to push off the ground, and that requires 10% less energy at push-off. So again, we think this has benefits to runners. So other specific construction differences between these shoes that help to achieve the functions. We're looking at I mentioned the rubber segmentation. We also can change the width of the shoe to provide additional stability. We have less segmentation of the crash pad and the heel, which helps to just provide greater heel attenuation and rocker. And that we have moved the tread point back slightly so that it helps the runner to start the transition to push off earlier. And that we've also lowered the heel ball drop so that it's not quite as high of a heel relative to the forefoot. Yeah. So one case study that I want to mention relative to a specific situation. This is an athlete who had painful toe conditions that made it running very painful. Had surgery to work on a bunion on his right foot, and calcaneus had Haglund's deformity that had gone untreated. And so through using features like the glide roll and the rocker geometry with greater support through the midfoot, and a last that was more closely shaped to the shape of his foot. These are features that were very beneficial for this type of a runner. And so through finding the right shoe for his particular habitual motion path, that's enabled him to continue running and reduce the amount of pain. So in conclusion, all people move differently. There's a large number of solutions that could be provided. We've tried to group those into functional needs, and I've highlighted two specific technologies. We have others that Brooks has developed for other functional groups. But these are two that we have identified that will benefit different types of runners to better achieve uh, their habitual motion path on this continuum of shoes that move with you and shoes that move for you. Um, and we would love to get to a place where there's an individualized solution for every runner. And this is kind of one step along our path of trying to get to that place. So at this point, I would love to take any questions that people might have.
All right. This was wonderful. So, for those of you who may have joined us a little bit late, this is Dr. Brian Conrad speaking on running biomechanics and applications to footwear. I do have a couple of questions that have come up, so I'll go ahead and pose those. But if any other questions come up, feel free to throw them in the chat or the Q&A session here. Brian, uh, first question, when you see these objective biomechanical improvements with the different foundational support approaches, are runners feeling those differences? And do you get that kind of feedback just from a single run, or is it more obvious over the life of a shoe?
Yeah. Um, Great question. I love this question about the runner's experiences, especially when it goes beyond just the what we can observe in the lab. Because yes, as I'm sure you're aware, when we test people in the lab, it's for a relatively short time. It's when they're fresh. We have them run for just a few minutes at a time in each shoe. And we do complement that with extensive field testing. And so we follow up all of those studies by sending shoes to people to use in the real world on their normal runs, and that we check in with them over a long period of time. And so our typical study may take 6 weeks. That allows us to get enough usage where we can really understand people's experience. And so we weight that very heavily. And we also have our perception researchers working very closely with the performance researchers to get a holistic picture of the function of the shoe. And so, yes, like we're constantly thinking about, do runners feel the features that we're designing? How does that show up for them? And we take that feedback very important. Uh, uh, Both aspects of the feedback, the perception and the movement, and try to create a picture of what the shoe is doing and an impact it's having.
Do your research partners use surface EMG and near infrared muscle oxygenation assessment to look at how these different technologies engage various muscle groups?
Um, we do not use a lot of EMG. We do use Moxie sensors. I don't know. I know we've been using them recently for several studies. At Nike, also they were using them for different studies. So yeah, I think muscle oxygenation is becoming like another way to get localized metrics uh, of muscle use. And we use that in combination with metabolic cost, where you get kind of the global impact, but then being able to see some of the regional specific differences has been very informative.
The questions are rolling in now. Can you touch on some of the common differences between walking and running shoes?
Um, yeah, there's a lot of similarities actually. We've noticed that you know the shoes that we make for running get widely used for walking, and that people generally have a very good experience in those. And so I think there's a lot of overlaps. The couple specific differences, if there's a shoe that we really are targeting to be primarily a walking shoe, we may increase the base of support and um, the use a slightly more stable foam for the cushioning, just to provide like better stability. Because a lot of times, if people are doing a lot of walking, they're probably also doing a lot of standing. They're using the shoes for longer periods of time, not just during like a specific running period. And so we want to make sure the shoe is going to be functional for all day use, and that it'll kind of work with somebody through that longer time period than what we typically think of for a running shoe.
And I, my $1 million question, the super shoe. I wonder if
Mm.
you can kind of comment on your thoughts with the rise of the super shoe, and
Hmm.
you can take this question whatever direction you want, but I know that there's conversation about should we wear this more often and get used to
Mm.
it, or do we just wear it in races? And kind of
Yeah,
your common thoughts on it.
yeah. I think that is one of the active debates that we were having. I think there's arguments on both sides of, do you save this for the time when you need it the most, and then train in a shoe that will help you to develop, the strength to better utilize the shoe when you need it. Also, there's concern over like, do does wearing a carbon plated shoe offload the muscles in the foot? Does it cause like pressure points or areas where you're kind of concentrating stress on certain bones in the foot? So I know some people are concerned about that. But we also know that there's an adaptation that takes place with the super shoes. And so if you're not accustomed to wearing them, you'll probably not get the same benefit that you would get if you've developed, kind of a gait profile that best utilizes the features of the shoe. And so I feel like that kind of sets up two different scenarios. Like you want to use a shoe that you're accustomed to and that your gait is adapted to. But also there could be long-term impacts if that's the only shoe you're ever wearing, that maybe you're not providing kind of the variety of stresses that your body could be responding to. And so I don't know that right now there's a clear answer on what the right answer is, but I will tell you, like our elite athletes, that's the exact same question they ask us. They want to know, and so we're trying to do the research to provide the best answers for that.
It's a good answer. And my understanding of kind of where we are with all of this. I'm going to pose one more question to you and then we'll wrap things up here. Um, there, you had some commentary about customization, individualization for shoe wear. What do you foresee for the future in terms of that becoming a bigger possibility?
Yeah, I still think customized shoes for mass markets are probably a ways off, but I do think we're at a point where we can start to explore how to do that for specific situations. There's a number of technologies that I think are going to accelerate what's possible. 3D printing produces a lot of very interesting opportunities to speed up the development. You don't have to create a mold of a shoe and mold it in a factory in Asia and then ship it over. You could print it. You could print a lot of different designs that are very specific. And so that at least introduces the opportunity where it could be maybe more cost effective. I would say at this stage, 3D printing shoes is still relatively expensive for the level of performance that you can get out of it. But that's something that I think if the price comes down, like could uh, uh, produce an opportunity to make customized shoes. But there's in the meantime probably going to be an opportunity where for elite athletes we do make investments in tuning a shoe specifically for their needs. And so that's work that we're doing right now. Uh, we're focused on the next Olympics is going to be in LA in 2028, and so thinking about how we can best support our athletes who are competing there through the best products, whatever that takes.
And I feel like the next question coming up is artificial intelligence, right? So where does AI
Mhm.
play some role in here and looking at gait and analyzing the best shoe? I feel like that's coming down
Yeah,
the line as well. Yep, for better or worse.
yeah, yeah. think it's definitely impacting a lot of what we do. I think we still are working in a physical world, and so we're not replacing researchers with robots yet. We don't have robots running in shoes, but we do still think there's an incredible value in like getting that direct feedback from real world runners, both in how they move and trying to understand all the signals that we can capture. So the way they move, the feedback that we get, even data on and off the run, I think can all be informative about the total experience. And so anytime you have that much data, having models that can help make sense of it all, I think are going to be incredibly powerful. And so I think like we're already at that stage where artificial intelligence is enabling us to look at much bigger data sets and see relationships and correlations with things that we might not have looked at in the past when we had to pick, a couple individual metrics or variables of interest. Now we can look at a much bigger scope and see what the impact is.
Well, thank you again for taking time out of your evening to present on this. I think this has been really wonderful. A lot of insight. I want to learn more about shoes now, so we're going to have to find some more time for more of these talks. So I very much appreciate it, and thank you to everyone who joined us this evening. We'll get this posted on our UVA Runners Clinic YouTube channel as well, and I hope everyone has a good night.
Thank you so much.
Thank you again, Brian. I appreciate your time and willingness to do this. This is great. And I'll shoot
Yeah,
you a
no
message when we
problem.
get it posted, all right?
Yeah,
All right.
happy to connect, follow up anytime.
Very cool. Have a good night.
Bye.
Bye.